Hi guys, welcome to this tutorial. I will talk a little bit about ShaderMeister that I mentioned in the previous one. I will show you guys how you can use ShaderMeister to do sort of like per surface control. In this case we have a window here that is currently receiving occlusion, but a window shouldn't actually do that. It's a transparent object, and essentially what I would want to do is to have one render where this window does not contain any occlusion, but it has a completely white surface. And I will show you how to do that with ShaderMeister as well as Dennis Pontonier's Pixelfilter and some of his tools for that. So first of all, I will just save this scene as ShaderMeister. And before I actually continue with that, I actually want to just increase the occlusion distance a little bit so we can see it better. So let's say 500 millimeters instead. And let's do another render for that. Okay, so if we compare the two, yeah, so we can see clearly that there is occlusion on that surface now. Good. So let's go ahead and play around with ShaderMeister. So we'll actually disable this pixel filter because ShaderMeister is kind of different. It's a master plugin / shader solution. So let's go in and add ShaderMeister. The first thing you should do when you're using this is to apply the shader to the surfaces. So let's do that. Let's add all shaders. It's essentially just goes through each surface and adds this little shader here. And this one actually doesn't do anything. When you click on this node graph, you actually open the global node graph that is resided within this master plugin. So essentially you can apply this shader, and as soon as you disable global shading enabled, it should actually render things exactly the way the original surface was set up. So let's try that. So right now, if I would render now, it's going to look crap because this scene is very dependent on global illumination and of course some ray tracing functions. But as soon as I go in and change those things here, so global illumination and ray tracing, we should be back to what this scene actually looks like before I do any global shading overrides. But you have seen what this image looks like before, so I don't have to show that again. So again, I will just disable these things, because the advantage here is that we are doing this on a scene level and not on a shader level, so we don't have to think about duplicating objects to deal with certain shading overrides and things like that. Okay, so ShaderMeister it is. And well, here's another thing that is really good with ShaderMeister: it works with VPR, unlike pixel filters and image filters that they are not evaluated by VPR, but ShaderMeister is. So that's really nice. So I've just set up a limited region here where you can see some of the window frame, like so, and the window, of course, the glass. So this object here is this window frame also contains the glass. It's the same object, but they are different surfaces. If they would have been the same objects, it would have been very easy to do this, because then I could just have brought up the actual properties for the object and make it a matte white object here. But I can't do that, so because it's a surface. But ShaderMeister will save us. So let's enable VPR here so we can see what we're doing. Right now it looks like this, and so let's open the node graph. let's find a occlusion shader, and I said 500 millimeters if I'm not mistaken. Okay, and if I bring that one into the color override, we are essentially back to where we were with the nodal pixel filter. The exact same thing is going on right now. The difference is, of course, that it's visible in VPR. So we need to filter this somehow, and if you have a ShaderMeister, you can search for filter. You should find a selection filter under the DB and W node tool here, node tools. And so if I would remove that, we can see that the B and W have their own section here, and then it was under selection, and there you have the filter. Okay, so I will take this ambient occlusion shader into new color and bring the color into color override, and nothing should happen, nothing should change. Sometimes when you do this with ShaderMeister, VPR doesn't update automatically. You might have to do a frame step like that to just force the update, so to speak. Sometimes you have to do that. Not a big deal, I guess. So what we need now is to tell this occlusion shader that it shouldn't actually apply occlusion to the window surface. So if I double click the filter, we have all sorts of filtering options here. In this case, I want to use surface name, so I will pick the surface. I know the surface is glass, so I'll pen that. And right now, again, I have to frame step to see what happens. And now we can see that ShaderMeister is applying the occlusion shader to the glass window. But I want inverse, so let's just invert the filter, and let's frame step again. So okay, we have taken care of the occlusion, but what about the surface, the glass? It shouldn't be black, it should be completely white. Well, that's easy enough. Let's just add a constant color, make it completely white, like so, and bring that into base color, and there we have it. So let's do an F9 render. Okay, so there we have that. No occlusion on the windows, or the glass rather. That's nice. And also, of course, when using ShaderMeister, since it actually applies that shader on the light wave shader tab, you have to save all the objects so that it actually is there. Otherwise, next time you open this scene, you will have to, of course, apply. It's easy. I mean, add all shaders and then you are done. So that's essentially what I wanted to talk about regarding ShaderMeister. So I will show how you can do a similar thing now with Dennis Pontonier's Pixelfilter. Hi guys, so this is the second part where I will show you guys how to use Dennis Pontonier's Node Pixelfilter to do a similar thing that we did with ShaderMeister. So let's bring up the interface here, and let's go into DP filter, and under the buffers we have mask objects and mask surfaces. So mask surfaces is the one that we want to use. So if I double click on this, I get this little list. So what I want to do here is to select the glass surface. Okay, let's take the occlusion in here, and before I continue, I will actually save this scene as a new scene. I will write this one, Node Pixel Filter, and I will set up a limited region as well, so that we save some time, like so. And let's do a test render for that. Okay, so right now what we have is occlusion being cast on the window, so I don't want that, so let's invert the selection here and do another test render. Okay, that's nice. So of course I want to apply a white, completely white color onto the window here. So let's duplicate this and invert selection, so we just have the glass selected. And let's add a color, which should be completely white. Let's bring that one in here, and let's just take a look at that one. And what happened there? Okay, this happens sometimes when working with this, with the pixel filter. So whatever you do, just save your scene and reload it. That should fix the problem. I'm not sure why that happens, but it happens. So if I do a test render now, what I should see is the actual window here. Yes. So that's okay. No worries. So now it's just a matter of adding these guys together. So I will just add a let's say a vector add. So that's nice. No occlusion on the window. And if we take a look at the alpha channel, well, maybe we would want a complete alpha. Avast is doing things. Let's close it. Thank you. So you can also affect alpha here, of course. So essentially what you do, it's this one here that we want to add an alpha to. So let's say a scalar, constant scalar, default is 1. Okay, so let's bring that one in here, and let's take that scalar into alpha. So now we should have an alpha channel that only contains the alpha for the actual glass. Yes. So let's search for an add node. In this case, a scalar add. So let's just take the scalar from that one, scalar from that one, and add that into the alpha channel. And we should now have a completely white alpha, if for some reason that is important. Okay, so that's essentially it. Let's do a full res render now, or full res or full res, mid res. And there we have that. No occlusion on the windows, and a completely white alpha channel. So that's it, I guess. Cheers, guys.